Good afternoon, this is Andy Schweitzer, and this is a little example of velocity, a bunch of stuff here. Velocity, we'll see a little bit of acceleration. Another example, so overall example, it's a kind of a thought experiment we'll have here. So let's imagine that a student, Mr. Stickman, takes a bowling ball and brings it on a rope up to an eye bolt, and let's say it has a bowling ball on the end of this thing. And this person is gonna let it swing. It's gonna swing down and follow a circular path, get close to the ground, and then it's going to swing up and eventually come to a point where it stops, and then it's just gonna continue back. So on this section, okay, let's analyze what's happening velocity-wise, acceleration-wise, and then we're gonna graph this thing on a graph. And you'll maybe have an opportunity to try this first. We're going to put on this thing position and then time. And we're going to kind of graph this out and see if we can figure out what's going on. Now, as we look at this again, maybe I could have drawn a little bigger version of this particular chart, but we'll make it work. So keep in mind that at the very tops of these things, the velocity equals 0 here, and the velocity equals 0 here. So it's stationary. Now, again, I can think of the velocity in terms of the x and y coordinate. What's happening on the horizontal situation? This would be a positive velocity. This would be a negative velocity. Or I could even think of it just simply in the vertical axis, where up is a positive and down is a negative. I could think of it either way I want to. It just depends on the parameters of what I want to do for my experiment. But in this case, for this experiment, I'm going to look at things in the XY horizontal. So from here to here, that represents this position right here. Okay, so in some sense, as the ball moves farther and farther and farther away, it should get farther and farther down this position. So you would expect it to end up somewhere over in the middle, somewhere here, and then end up back here where it starts. So I'm going to erase this little thing here, but if I start out right here, I would end up farthest point away and then come back as I swing back. So either way, as I analyze this picture, you should note that my velocity is going to start relatively small as I go this way, but I'm traveling to the right, so I'm going to have a positive velocity, and then it just gets bigger and bigger, and then something happens right here. I'm still traveling to the right, so I still have a velocity that's positive, but you'll note that it gets smaller and smaller. And then, okay, what about when it comes back? Well, in this case, as it comes back, it starts out slow. It gets faster and faster. So I have a negative velocity, negative velocity, negative velocity. But of course, it's getting faster. And then this thing gets negative velocity, and slowing ever down until it gets back to its essential stop again. So you note that at some point, because I'm changing my speed, I have an acceleration issue here. I am accelerating down, and this is the point where I'm the fastest. Either way, I'm fastest in the middle, and I'm slowing as I go up or accelerating as I come down. So my acceleration is going in this direction, and it is going to be positive acceleration. In a sense, if I'm traveling in that direction, I'm accelerating in that direction, I would get faster. And then as I go up, my acceleration is going down, and I have a negative acceleration. That's why that negative acceleration starts chipping away at my velocity, but it's the same, consistent every time. My acceleration is constant. The acceleration of gravity is 9.8 meters per second squared. And then, of course, on the way down, I still have this negative acceleration, and then as I go up, I have a positive acceleration. So the fact that the positive acceleration on the left side, the negative acceleration on the right side, if I'm traveling down, I pick up speed. As I go back up, I lose speed because of the acceleration. But as I go down, now my velocity is in the same direction as my acceleration, so I start picking up speed here until I get to the bottom, and then once again, I start losing speed. So take a minute and let's think about what this graph is going to look like. Okay, position-wise. Now I mentioned this is really the x position. So I could put my starting point anywhere I want, but I'm just going to choose right here as my starting point. Here's my ending point because the ball is going to swing all the way up and then swing back down. Again, I'm just going to do one full swing there and back for this particular graph. I know that when I get to this end point, essentially I have no velocity. So I'm looking for a flat piece. Now, just an FYI, looking at slope here, okay, if we have a position, okay, which is time graph, if I have something that's flat, there is no acceleration here, okay? They're the same position over time, they're sitting still. I could have a couple options now. I could increase in the positive direction. Okay, this would be a positive velocity. Okay, or I could have, but because it's straight, it would be constant. I could also have a negative velocity. I could have something that is, okay, again, this is constant. Or I could have something that is accelerating, okay? Now, with this particular graph, I have an abrupt acceleration or abrupt deceleration, or I should say, yeah, well, decelerating at a negative position. So, again, going up, going down, they're traveling in different directions. These slopes look relatively similar. So they're both traveling maybe the same speed, but in different directions, okay? Now, I could have something that's traveling like this. Now, that is just a something that is accelerating. Okay, my speed is different everywhere along here, and I'm increasing in speed. This is a positive acceleration, as opposed to something that is looking like this, which is a negative acceleration. Okay. So keep that in mind. Now, as we flip to our next screen, okay, let's go to this guy, the last one here. It's not, I don't like that. Where is it here? Let's go to a new slide. Okay, now, in this case, let's draw what we got here. And there we go. Now, in this case, a little bigger. Okay, I'm going to mark my initial point being right. Let's just go right here. And my ending point is going to be right here as well. So this is my middle point here. So take a moment if you want and sketch out what you think the graph looked like and different points to it. Okay. So take that moment. That's great. But either way, let's look at the answer. Now, let's look at what's happening in the actual drawing here. The ball is swinging from here over to the farthest point away. Okay, now so this point is right here, and this point now is the farthest point away, which is right here. So at some point at the end here, we do know at this point this is going to be relatively flat. It stops moving for a very short period of time. And we do know that this point is relatively flat, and we do know the end point is like it's not moving there either. Now we do know that as I go in this direction, I am accelerating. I have a positive acceleration until I get to the middle point, which is probably right about here. So something significant kind of happens right in the middle here. All right. And then something happens to the acceleration right in the middle here. That's going to represent, if I drew this side, it would represent the ball swinging back. Okay, and that middle point is right here. Okay. So now at this point, the slope is going to represent my velocity. So I'm constantly going to start here and end in the middle point here, but something's happening here. I'm increasing in my velocity in the first half, and I'm decreasing in my velocity in the second half until I get to 0. So right about here, what I want this graph to look like is, let's say this is the middle point, right here. I am going to be increasing and I'm going to be accelerating here. So of course we know that in the first half I have a positive acceleration, the second half I have a negative acceleration. So I'm decelerating. So this would be something that is accelerating. Again, it's hard to draw, but it's sort of a cupping direction. That is accelerating. And then in the second half, I'm slowing down. So I'm decelerating, still traveling in the same direction. I'll try and handle this a little more better, but it looks more like this. Okay. So the drawing kind of looks like this. All right. And then the same thing happens on the other side, except we start on the way down, and it's swinging back. It's going this way now. We are going faster, okay, it's picking up speed. So now in this case, if I go down, I am traveling my greatest distance. Okay, let's sketch this out here. I mean, biggest pickup of distance. Okay, I'm picking up, getting steeper and steeper as I go this way. So I have, in this case, a positive acceleration, or I'm picking up speed. Okay, but now as I go the second half, I start to slow down, and it is mirrored the other way. Eventually, I get back to my flatness. So the slope is the speed. I have my greatest amount of slope right here. As I increase my slope right here, and also right here. Okay, the steepest point. At this point, this is the steepest, and the steepest right here. In this point, okay, so we have a positive velocity, positive acceleration, positive velocity, negative acceleration, slowing down. Velocity equals 0. Okay, technically, you could say it's still acceleration, gravity is still there, but pauses for a moment. Now I have a negative velocity, okay, and I have a negative acceleration, so I'm picking up speed to a fastest point I have right here, and then I have a negative velocity still traveling to the left, but I have a positive acceleration now, and eventually knocking me down to a 0 here. If I were to stretch this out over a longer period of time, let's just say we marked out 5 swings, what's going to change here? A lot longer. This is my starting point, right here, okay, and then this is just time here. Now let's just say we have each mark here is a full swing there and back, and so I'll make somewhat even marks. Okay, so I have full swing 1, 2, only 4 of them. Okay, now this is a little unique because it's going to go swing up all the way across and come back down. Now every time it swings, it doesn't get quite as far away, and it doesn't come back to the exact same spot. So it might be like this. Ooh, that was a bad arc. You get the point. And then at this point, it might only go like that. And then it might go like this. Eventually, it will just flatten out right in the middle. This would be my middle point right here. Many swings. But the funny thing is that ideally is that the swing actually takes the same amount of time. From point 1 to point 2, it takes the same amount of time, just traveling slower. Alright, that is a more complicated example of position and acceleration, directions of graphs. But good example.